Hi, in this video, we want to take a look at text classification with Keras, and we're going to be doing this inside R. Okay, so the situation is that I want to build a model so that I have a text coming in, and I want to classify it as positive or negative. Okay, so this is very similar to sentiment analysis. Basically, I want to achieve sentiment analysis, but with a different model structure. Why am I doing this? Really just as an example of why or how we could do similar activities using Keras. Okay, so honestly, for this project in particular, if I was doing this in real life, I would just go directly to sentiment analysis. But for the purpose of this video, I want to demonstrate two-level classification using text. Okay, and so what we're going to do, we're going to take some data. The data is text from movie reviews. We have a target column of positive and negative, and what I want to do a two-level classification on each of the texts. And so, like in the future, how I would use this. Let's say that I work for a movie studio, and people are posting things on social media. So what I could do, I could grab the ones that are positive and then post those reviews, those ratings, those comments to like the web to say, hey, this is what other people are saying about my movie. Therefore, I can convince people that my movie is good, that they'll go and see it, they'll buy it, whatever. All right, now this example is taken from TensorFlow.rstudio.com. All right, so I just went through, I modified things, worked through this so I understand completely what's going on. And this is a good collection of tutorials. Disclaimer time, I would not launch this model professionally, straight up. Now, the author of the tutorial knows this. If you go deeper into the tutorial, you go 2 lessons after this, they start talking about the problems with this particular model. The goal of this video is not to build a good model, but to show how you could build a good model. The combination of model structure and data for this particular case is not solid, but the methods used to build the model are good. So if you keep watching my videos, I'll come out with another one showing how to dig in and get you a good solid model. But for now, this is just kind of like baby's first steps. We're just going through the motions just so that we have a good solid understanding of how to do text classification using this TensorFlow approach. All right, so for this particular example, I'm going to take movie reviews from Kaggle. And so to get the data from Kaggle, what I need to do, I need to go to Kaggle, create an account, and get an API going. Once I have my API, they're going to send me, or I'll be able to download a JSON file, and it's called Kaggle on my computer. And so what I need to do, once I have that API information in that JSON file, whenever I want to get the data from Kaggle, I go, hey, here is my information, send it to Kaggle, and Kaggle goes, okay, that's a good API, we'll push out the data to you. Now, how I do this specifically in R is that I use the pins package. And so here, board register Kaggle. So Kaggle calls, their setup boards. And so I'm just going into a particular board, registering with my JSON file. And then I'm looking for, so pins is more flexible than just Kaggle. Since I want to be able to go with like potentially I could go with like any of the available options inside pins. This is not specific to a particular website, what I'm doing. When I get to here, when I get to board register, I'm being specific to Kaggle, and pins will work out the particular details for me of how to take the JSON file that they gave me, send it to Kaggle, and then I'm able to grab the data from them very nicely. All right, so now to get the data, what I'm going to do is I'm going to use, once again, the pins package. Pin get is where I'm getting the actual data. Now, what's going to happen is that it's going to save a bunch of stuff. So here I'm going into, this is where the actual data set is. I'm calling the particular data of movie review. It's on the Kaggle board. And what I'm doing, that's actually going to be a whole list of places I can get my data. And it's going to be saved on my machine. Well, for this project, there's a whole bunch. For this project, I only need the first one. And so I just went ahead and modified the original code to just say, grab the first one. I recommend if you're going to be getting into the pins package and working through stuff, go through and look at the actual output here, get familiar with it, and then, make sure that you're grabbing the item that you actually want. All right, so at this point, I have the CSV on my machine. It's downloaded, and I need to grab it. So here, pin get movie is the actual file path on my machine. Okay, and so what I'm doing here, I'm telling R to go to this file location, going to read it as a CSV, and then treat every column as character vectors, as character strings. All right, now R a lot of times wants to put things in factors. The read R is not so bad about that. The reason if you don't know what to do, read in your data as a character string. Why do we do this? Well, think about social security numbers. If I have social security numbers listed in my data set, the computer sees that and it's going to think, oh, those are numbers, and it's going to treat them as numeric. Okay, well, if I have a leading zero, that leading zero is going to be dropped, and that can be a problem down the road. So anytime you're working on a project, if you don't know what the column type is, put in character and then figure out and work with it from there. Then if you're going to as you figure things out, you can change these guys here. So this C means character. I could put N for numeric. All right, so let's go ahead and take a look at our data set. I'm just going to look at the first 6 rows using the head function. And so fold ID, CV tag, HTML ID, sense ID. We really don't care about these for this purpose. What we care about is the text, and then is it tagged as a positive or negative review. All right, so this is the text column. It's kind of hard to read because it's so wide. All right, so the very first entry is films adapted from comic books have had plenty of blah, 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 blah. And you can see it's quite a bit. And then the second is Ted by Alan Moore with Eddie Campbell, who brought the medium to a whole new level in the mid 80s and so on. Here is the third one, fourth, fifth, and sixth. So something that we can notice right away is that first and foremost, everything is in lowercase. Okay. Now another one is that somebody went through and did data prep to make sure that parentheses are separated from actual words, and then quotations are separated from actual words. Okay, so you can go through and you can see that the grammar is a little bit off. The reason for this is because of upcoming data usage, how we're going to go through and work through this. Now, the tag is our target variable, positive or negative, and it's sorted positive up top, negative down low in the data set. All right, so what I want to do, I want to build a model that can take this text and then model positive or negative off of that column. And we're going to use TensorFlow to do this. All right, so just a quick look at what's going on. I want to go ahead and just get the count on each of the tags, positive and negative. And to make this quick and easy, I'm going to use the Magrittr package. I'm going to use piping. So Magrittr is where the piping operator is. And so I'm going to go movie piped into dplyR's count, and I'm specifically interested in the tag. And so when I look at this, it's approximately 50-50. Remember that whenever I'm doing a classification problem, in general, my models will perform best if I have equal size of distribution. If I was to have 98% of my data was one category and 2% was another category, then there's a data imbalance, and it's going to be harder to get certain metrics of performance to be meaningful. And so 50-50 is usually the best case situation. Now, for text analytics, if I'm using a document term matrix, I can be in the situation where I have a lot of predictors. The more predictors, the more parameters I have, the more data I want. All right, so here we've got about 64,000 observations. Well, honestly, for this project, this is rather low for the point of using TensorFlow. All right, so now let's go ahead and actually build the Keras model. And so what we're going to do, first and foremost, we're going to take our text and then we're going to convert it into a format that a computer can use for supervised learning. All right, so what we do is we take the layer text vectorization function in the Keras package. I'm going to specify the number of words that we can use and the maximum length that we can use. All right, so what we're saying is I want at most 10,000 words, and I want the maximum length to be 64 when I'm considering the length of a review. The reason why I'm doing this is that I'm going to reduce down the text to words that are more frequent. I want to only use words that are informative. If a word only appears, let's say, 3 times out of the entire data set, if a word appears 3 times over 64,000 reviews, then that word probably doesn't have a lot of oomph in it. All right, we want to have words that have a frequency of use, but also a variety in the frequency of use. And so these parameters say, hey, don't use everything, trim it down to only words that, from a count point of view, are going to be useful. All right, so now the next step is, actually, something I need to point out. You'll notice that on this step, there's nothing involving my actual data. Okay, so there's nothing for my actual data being used. Therefore, I need to incorporate my actual data for this. And so what we're going to do is we're going to use the adapt function. I'm going to pass through what I just defined of the layer text vectorization, pass that to adapt, and here is my actual data. So what it's going to do, so here I have like the text to document term matrix structure defined. What this does is it actually fits the setup to the data I have to work with. And we can see that the output of this function of this piping is something from the Python suite of items. And now if I actually look at the output of the layer text vectorization, where I say, hey, take the matrix, movie text in column, number of columns equals 1, I can actually see my document term matrix. Now, something about this is I notice that I don't know which column corresponds to each word. It went through, it figured out which ones should be in there, which ones should not be. And so my guess is that overall, the columns to the left have the most frequent words, the columns to the right are the least frequent. You'll notice I have 64 here for the number of columns. And we put max length equals 64. That's not a coincidence. It's the number of columns is equal to max length. Now this 64 is just happenstance. That's just because of how it's coded in the machine. From a statistics point of view, no connection. All right, so now let's go ahead and define the input layer. All right, so what we're going to do, we're just going to go with a vector format for the input layer. So we could have multiple layers going on, or shape-wise, multiple aspects. We're just going with one. and all of the data is going to be a string. And so I'm passing this to input into my input layer. And so here we get everything going. So it's a vector, TensorFlow string. This is my first layer of input. That's what the 1 is for. Now let's actually define what the output layer is going to be. So what we're going to do, we're going to pass our input layer in. We pass that to our text vectorization that we just talked about a moment ago, my very first step when I was building the model. Now I'm going to embed the document term matrix, and we're going to specify the number of dimensions. So I'm going with the number of words, 64 columns plus 1. So when I'm doing that plus 1 is going to be that bias term. All right, so in statistics, we would call it an intercept. That plus 1 is the intercept in statistics. In machine learning, we call it a bias. And we're going to have a coefficient. In statistics, we call it a coefficient for each document term matrix column, each data column. In machine learning, we call it a weight. Conceptually the same thing. And then my output dimension is my maximum length. Okay. Now here, if I don't do averaging, I get some wonky results. Some things don't work out. So to make sure that everything fits the way I want it to downstream, when things are getting kind of weird and incoherent, I just take an average. Just go through, average it, move on. And so what this does is layer global average pooling sets it up so that if something doesn't have the right structure, the right format, it just takes what I've got, averages it, puts it in the format we need to keep moving in the direction of fitting. Now here's my dense layer. So here's the actual units I use in my neural network. And I put max length equal to, or so the number of units equal to max length. That was just a choice of mine. I think it was like 8 or 16 in the original. I was just playing around, just seeing what's going on. The activation function is ReLU, standard format for beginning neural networks. Remember, the activation function is the inverse of the link function in generalized linear models. ReLU is flat and then it goes steep, and so the parameter there is on the slope of the steepness. Now, the output dropout. What this does, this looks to see, do I have parameters in there? Do I have weights that look like they're contributing to overfitting? If I'm overfitting, then I want to make a correction. So what this does in an automated manner, it goes through, it checks to see what looks like it's not, from a data point of view, helping the model. If it's not helping the model, kick it out. Bigger the number, the more stuff gets kicked out. And then last but not least, this takes everything I've got and does a classification on my 2 levels. All right, so if you remember logistic regression has like this S curve going on in its modeled probability. We're taking a very similar shape to this, a sigmoid. We're taking an S-shaped curve, and we're just going, one side of the S, when it's higher up, corresponds to it being positive, high. So the high modeled probability of positive, low down on the S is lower modeled probability of positive. Well, if it's a low probability of positive, that means it's a high probability of negative. And so in other classification schemes, I need a unit for every single level possible. Here, what we're doing is, because I only have 2 levels, I can make this simpler by doing sigmoid. And here we can see that we have a tensor going on. End up having just a length 1 vector for my output on each one, because it's a classification of 1 unit is the output. All right, so now let's actually define the specifics of the model. So here, what I've done, I've figured out what the input is, I figured out what the output is, I figure out the document term matrix, but I haven't actually set up what are the connections between the nodes inside my neural network. So what I'm going to do, I'm going to use Keras model. I'm going to specify the input. I'm going to specify the output. And now what I'm going to do, I'm going to say, hey, figure things out. So we're going to use the Atom optimizer to figure out the specific values for ReLU. My loss function, as the system is trying to figure out how to improve the parameter values, I say use binary cross entropy. And then the metric that I'm going to use to evaluate my model is accuracy. Accuracy is a good choice when I have balanced data. If I had imbalanced data, accuracy is not a good way to go. I need to change it up. Here, we're about 50-50. Let's go ahead and go with accuracy. Okay, so things that are important. This layer here, I see I have parameters. So we're taking, this is the number of parameters I have going from my text, my document term matrix, into the next layer, which is, I'm going to have 4,160. And then from there, we have 65. So we have 64 columns, and 64 columns and with like 10,000 words means that I've got that, you know, that's a good number. And then it just keeps on, you know, growing. So this is the parameters going from the text to the first level, and then from that level to the next, and then that level to my final one is just 65, 64 plus 1. Okay. And so our total parameters is, 640,000 parameters. That's a lot of parameters. All right, so now that defines what the structure, that defines the actual relationship of between, or that, not the specific relationship, that defines the connections between document term matrix, nodes, and positive or negative. Now I actually want to fit those individual parameters. Well, to do that, I need to pass my data. You'll notice in the previous steps, I have not actually used my data yet, except for in the document term matrix. I haven't actually like worked out the details. So what I'm going to do, I'm going to take the text, I'm going to pass it into the system. I'm going to say my target variable is positive or negative. But so specific to what's going on is I need to have zeros and ones for that sigmoid model structure. All right, so for the sigmoid model structure, I'm going to choose that larger values correspond to positive, lower values correspond to negative. And the sigmoid is modeling the probability of positive, the probability of negative is 1 minus that probability. So big probability, probably positive, low probability, probably negative. Now, to get decent values off of this model structure, you have to have a very low validation split. This is why I would not use this model in particular, but it's good enough for an example to show how to do it. And when I run this, we can see that my validation loss is 0.62. My validation accuracy is about 0.7. My loss is 0.52, and my accuracy is about 7.4. All right, so something that's very important to us is if my training accuracy and my validation accuracy are far apart, then that's a sign that I'm overfitting. Here, 0.75 and 0.7 are close enough that I'm okay with this. Almost always, your training statistics will be better than your validation statistics. If I see validation statistics are better than my training statistics, usually I have an outlier in my training data. Here, I see no indication of that. It may be there, maybe it's possible, but whatever. And so now I want to visualize the outputs, see what's going on. And so up here is the loss function. And you'll notice that the training aspect just keeps on getting lower. Down here is the accuracy, and it keeps on getting better as time goes on, it's starting to flatten out. And then the validation kind of bounces around. The validation bounces around because I had such a small validation set. If I had a larger validation set, it would look like more like a consistent curve. But I feel like this is for a weak project, for a project where it really doesn't matter if I have a low accuracy, this would be an acceptable model. But honestly, I could do better. And in the next couple of videos, I'll show you how. So I hope you really enjoyed this video. Take care and goodbye.